Performance optimization is one of the most satisfying things you can do as a developer. You find the slow thing, you fix it, and you watch the numbers improve. But here is the uncomfortable truth. Most performance work is wasted, not because the optimizations are wrong, but because developers optimize the wrong thing. They guess where the slowness is instead of measuring. They rewrite an algorithm that takes 2 milliseconds while ignoring a network call that takes 800 milliseconds. Today we are going to talk about where time actually goes in an Android app, how to find it, and why the answer almost always surprises people. There is a principle that applies to almost every performance problem. 80% of the time is spent in 20% of the code. This is not an approximation. It is consistently what you see when you profile real applications. Most of your code runs once, quickly, and is irrelevant to performance. A small number of hot paths, tight loops, frequently called methods, critical rendering code, dominate the runtime. The implication is huge. If you optimize code that is not in the critical 20%, you are rearranging deck chairs on the Titanic. You could make that code 10 times faster and the user would not notice. This is why profiling is not optional. It is the difference between productive optimization and performative optimization. Developers are terrible at guessing where performance problems are. I do not say this to insult anyone, I include myself. Our intuitions about performance are shaped by what we find intellectually interesting, not by what actually takes time. We worry about the n squared sort in a list of 20 items, which takes microseconds, and ignore the JSON parsing of a 2 megabyte response, which takes hundreds of milliseconds. We obsess over reducing object allocations in code that runs once per screen, and miss the overdraw that is causing dropped frames every single scroll. The human brain is wired to find complex things threatening and simple things safe. But in performance, the simple things I/O, rendering, memory pressure are almost always the real culprits. Android Studio gives you a profiler that is honestly remarkably good for a free tool. Let me walk you through what it offers. The CPU profiler shows you which methods are running and how long they take. The memory profiler shows you object allocations, garbage collection events, and heap composition. The network profiler shows you every HTTP request, its timing, and its payload size. And the energy profiler shows you which components are keeping the device awake. To use the CPU profiler, you attach it to your running app, trigger the user flow you want to measure, and record a trace. The trace shows you every method that executed, how long each one took, and the call chain that led to it. This is not guessing. This is data. When you record a CPU trace, you have two options: sampling and instrumentation. Understanding the difference matters because it affects what you see. Sampling works by periodically checking which method the CPU is in, say every 1 millisecond. It builds a statistical picture of where time is spent. The advantage is minimal overhead. Your app runs at nearly full speed. The disadvantage is that you can miss very short methods. It is great for getting the big picture. Instrumentation records every single method entry and exit. You see exact timing for every method call. The advantage is precision. The disadvantage is significant overhead. Your app runs much slower with instrumentation enabled. This distorts the results because the overhead itself takes time. My recommendation: start with sampling to find the hot areas, then use instrumentation on specific sections if you need precise timing. For deeper analysis, especially for UI performance, you want Systrace or its successor Perfetto. These tools trace system-level events, not just your app's methods, but the entire rendering pipeline. When you capture a Perfetto trace, you see the choreographer scheduling frames, the UI thread processing layout and draw calls, the render thread sending commands to the GPU, and background threads doing work. You can see exactly where a frame exceeded the 16 millisecond budget and why. Was it layout, draw, synchronization, and expensive composable recomposition? Perfetto shows you the full picture across all threads and system processes. It is the most powerful performance tool available for Android, and it is completely free. Both the Android Profiler and Perfetto show flame charts, and knowing how to read them is the single most useful profiling skill you can develop. A flame chart is a stack of horizontal bars. Each bar represents a method call. The x-axis is time wider bars took longer. The x-axis is time wider bars took longer. The axis is the call stack, the method at the top called the methods below it. Here is the key insight. Look for wide bars. A wide bar means that method took a long time. If the wide bar is at the bottom of the stack, the method itself is slow. If the wide bar is at the top and it is made up of many narrow bars below, the method is slow because it calls many things. This distinction matters. If the method itself is slow, you optimize its algorithm. If it is slow because of its callees, you look deeper to find which callee is the actual bottleneck. Follow the widest bar down until you find the culprit. After years of profiling Android apps, here is the pattern I see over and over. The biggest bottleneck is almost always I/O, not computation, not algorithms. I/O, network calls that take hundreds of milliseconds, database queries that run on the main thread, file reads during startup, image loading from disk, shared preferences reads that block the UI thread. This is counterintuitive because I/O code often looks simple. A one-line API call, a room query, a preferences read. These lines look harmless, but each one potentially blocks a thread for hundreds of milliseconds while waiting for hardware. The CPU is idle, it is just waiting. This is why understanding the difference between CPU-bound and I/O-bound work is so critical, and we will cover that in detail in the next video. Let me give you a real-world example. You profile your app's cold startup and find it takes 3 seconds. You expect the problem to be your complicated splash screen animation or your complex dependency injection graph. But when you look at the trace, here is what you find. 800 milliseconds, shared preferences initialization on the main thread. 400 milliseconds, deserializing a large JSON config file. 300 milliseconds, initializing your analytics SDK, which makes a synchronous network call. 200 milliseconds, room database initialization. The rest is actual UI work. Over half your startup time is I/O that happens to run on the main thread. The fix is not algorithmic optimization. It is moving I/O off the main thread and deferring non-critical initialization. Simple changes, enormous impact, but only because you measured first. Just as important as knowing where to optimize is knowing when not to. Do not optimize code that runs once during initialization unless it is blocking the main thread. Do not optimize a loop that iterates over 20 items, the overhead is irrelevant. Do not optimize an algorithm unless the profiler shows it is a bottleneck. Do not replace a hash map with a sparse array unless you have profiled evidence that it matters. These micro-optimizations make code harder to read for negligible performance gains. Your time is better spent on the things that dominate the profile, I/O, rendering, and memory pressure. Let me give you the workflow I recommend for any performance investigation. Step 1. Define what slow means. Is it startup time, scroll junk, screen transition latency? Be specific. Step 2. Measure the current state. Record a trace with the profiler or Perfetto. Get a baseline number. Step 3. Analyze the trace. Find the widest bars. Identify the top 3 time consumers. Step 4. Fix the biggest one, not all 3, the biggest one. Step 5. Measure again. Did it improve? By how much? Step 6. Repeat from step 3 until you reach your target. This is disciplined engineering. Each fix is validated by measurement. You never waste time optimizing something that does not matter. Here is the most important lesson in this entire performance section. Never optimize without a measurement. I will say it again, never optimize without a measurement. Your instincts about performance are wrong. Mine are wrong. Everyone's are wrong. The profiler is right. The trace is right. The numbers are right. Trust the data, not your gut. When you profile first, you accomplish more in 1 hour than a developer who guesses accomplishes in a week. And the best part is, the fixes are usually simpler than you expect. Move this off the main thread. Defer that initialization. Cache this result. Resize that image. Simple changes, huge impact because you targeted the right thing. Next video, we are going to dig into the fundamental distinction between CPU-bound and IO-bound work, and why understanding this changes everything about how you write concurrent code.